Okay. So let's talk about the word we might recognize.
What?
Polynomials. Okay, and confusingly, the way I'm going to talk about polynomials is first I'm going to start with something that's kind of a really special case. Okay. Let me define. So a monomial is one of three things. A number. You guys all know what numbers are?
Yeah.
Yeah.
You got that one? That's the biggest lie I've ever told you. Go with it. It'll be fine for a while.
All right, Joe.
Okay.
Do we know what numbers are? Okay.
There's some weirdness there that we haven't maybe appreciated. The concept we have of numbers is totally fine as long as you don't look at it too hard. So just promise me that you're not going to look at the idea of numbers very hard and we'll be fine.
Too late.
Okay, so
A number is just
A
something
number?
that we call a certain quantity.
Okay, stop distracting him.
that's the problem. Okay, so a number, a variable, to a whole number power, or a number times a variable to a whole number power. Cool? One of these three things. You guys need examples?
Nope.
Yes.
Yes? Okay. Monomials. Example.
1.
1. Thank you. Yes. F of x is 1
1 million.
is a monomial. M of x per million is 10 to the 6th. Is it million?
Yeah.
Totally a monomial.
X.
X.
X of X.
Oh.
X of X equals
Okay. X of x is x.
And then
Totally.
What about
X
square
raised
roots?
to
Okay.
Square root.
Good question. Square roots. Are they a whole number power?
20. Nope.
What power are they?
1/2 power.
They're the 1/2 power. So they're not a whole number, they're a rational number. So those go in the non-example box.
So no.
So no. So S of x, say, is the square root of x. And this is important. I'm going to build this list on purpose with some examples and some things that are. Okay, what else do you guys got?
X of 10 to 6.
Sure. Which I'm going to call capital M of x, because it's like little m of x, except better. So x to the 10 to the 6. Really, x to maybe 10 would be better. X to 1,000 would be maybe more obvious. But 10 to the 6th is in fact a whole number. Right? It's a counting number. Let's go with this.
Yeah.
Okay. How about z of x is 0? Is that a monomial?
It's a
whole number.
it's a whole number with a whole number power.
It's a whole number. And so it's specifically
A number.
a number.
Yeah.
You guys with me on that?
Yeah.
So you could even think about like z hat of x is 0x to the 0.
That's awesome.
Okay.
Right?
Yeah.
That's still 0.
Yeah.
Those are the same function.
1 times 0 is 0.
You could even think about z double hat of x is just x to the 0.
Why are you doing hats?
I'm just decorating.
Okay.
Like,
It's like
naming conventions are your own, so feel free to name things however you want. I like hats, so I put hats on my variable names.
nice.
So, what's x to the 0? Is that one already up here?
Yeah.
Yeah, that's 1, which is in particular a
Function.
number.
Monomial.
Guys cool with this? This one's a little bit weird. This one has a small problem with it.
It's 1.
Really, probably I should make this. Yeah, let me just say natural number power. That'll. What's the difference between the whole numbers and the natural numbers?
It excludes 0.
It excludes 0. So what's the problem I'm trying to sidestep right now?
The 0 power.
Yeah, I'm trying to sidestep 0 to the 0 power.
Oh, yeah.
You see that?
Because then that'd be 1.
I could make a definition for that, but I'd have to force something, and I don't really want to. So I'm going to put this guy back over there in my non-example file. The reason I put it in my non-example file is that 0 to the 0 is not 1. You see that? 0 to the 0 is undefined.
Can you say again the difference between natural and whole?
Yeah, natural number is a counting number. 1, 2, 3, 4, 5.
Yeah.
A whole number is 0 or a counting number. So it's
So it includes
0,
0.
1, 2, 3, 4.
Okay.
Yeah, so
So
the only
natural
difference is
just
that
doesn't
I just excluded 0 from my list. And the reason I excluded 0 from my list is later I'm going to want to say something about, I'm going to want to say that all monomials are everywhere continuous or something ridiculous. And if I leave x to the 0 in there as a monomial, x to the 0 is not continuous at 0.
That makes sense.
So I either have to fix that now or later, and now is probably easier. You guys all cool with that distinction? Let's see. How about sine of x? Where does that live? Is that a monomial or not monomial?
It's not. It is?
It's not a number, right? It's a function. Is it a variable to a natural number power? Like, is sine of x x to the 15th power? No, not for any value of 15. And it's not a number times a variable to a, oops.
You were correct. So it's not. It's a non-example.
So sine of x is a not example. How about cosine?
All tangent functions. I mean, all trigonometry.
Yeah, basically, and the other trig functions, the lot of them. Let's see, what's your favorite example of a monomial that you use all the time?
1.
1, good. What's your second favorite example?
X equals 2.
Oh, I already have my second favorite example, x, right? And then,
B.
so 1 and x and,
0.
damn it, that's a good one too. How about x squared? Is that a monomial?
Yeah, totally.
Yeah?
Yeah.
It's a variable, x, to a natural number power, 2 specifically. So, I'm going to call that one,
You can put it in front of x. You can make x because examples is also x.
cool. Down with that. Let's see, what else? There's going to be a whole long list of them, right?
Yeah.
X to the 3rd, x to the 4th, x to the 5th, x to the 6th, x to the 7th,
All the way up to x to the 10.
and all sorts of numbers times those things, right? You guys with me on that?
Yeah.
Okay, cool. And everybody's good on non-examples? Okay, a lot of the time we tend to think of monomials as integers and x's to whole number values or integers times those things, right? And it's a little bit more general than that, right? So specifically, what I want to give you is something like t of x is pi x squared. right, is a monomial because pi is just a number. You guys see that?
What if it's just pi? It's still monomial.
Yeah.
Yeah.
And pi is, so
X to the 0.
p of x is pi.
It's x times x to the 0.
Yep. Oh.
So if you have a population model, that's a monomial.
If you have a population model, so what's a population model?
Or p to the t.
P of t is
P0
p0 e to the rt.
Yeah. P0 size.
Well, like, as long as R and T.
P0 is probably an integer if you're dealing with a population, right?
R and T would be
But-
non-natural numbers.
E is a transcendental number, right?
Different thing
And
entirely.
the variable's in the exponent.
Not necessarily.
You guys see that?
Yeah.
It doesn't have to be a whole.
So so there's two problems with it. E is not a variable, right? And the stuff in the exponent isn't a whole number or a natural number, it's a variable. You guys see
So
that?
any variable in the exponent.
So it
position
should be
is
noted that there's a difference between what we call a power function and what we call an exponential function.
Yeah, exponential function is,
An exponential function is a number raised to a variable,
and then it's the other way around. with power.
and a power function is a variable raised to a number.
Exactly.
You guys see that?
Yeah.
So all the exponential functions, right, where the variables are in the exponent, are those ever going to be monomials?
No.
Nope. They're all going to be in the non-example pile. You see this? Most of the functions you guys know sit in the non-example pile. You guys see that?
Yeah.
Like, it's really special to be either a number or a variable to a natural number power or a number times a variable to a natural number power. Like, that's only three things, right?
Yeah.
There's a lot of functions in there, right? There's infinitely many functions in there. In fact, there's like infinitely many choices for the number and then infinitely many choices for the
There's a
variable's power.
There's a lot of tangents.
So there's a lot of things in there. But there's way more things over here.
More than infinity.
More than infinity. Yeah, it's totally great.